Hi children, good morning. Welcome back to our session. So what is our chapter, lesson? It's about the sound. So in the last class, we have learnt about the characteristics of the waves. What do you mean by waves? What is amplitude? What is frequency? What is oscillations? What is the time period? This and all we have learnt. So today let me see that through a small video. Before that, let me see what do you mean by the wave. Waves transfer energy from one place to the another through a series of disturbances or vibrations that carry the energy. What do you mean by the wave? The waves transfer energy from one place to the another through a series of the disturbances or vibrations that carry the energy. So what are the characteristics of these waves? Amplitude, wavelength, frequency, speed and the time period. So already we have learnt about this, and through a small video let me see what is this. Okay, carry on. Watch the video children.
Waves. But first, how do we define waves?
Excellent questions. Waves transfer energy from one place to another in a medium through a series of disturbances or vibrations that carry energy. Here are the basic features of waves: amplitude, wavelength, frequency, speed. These four quantities describe different properties of waves. Let's discover what each of these mean. First, let us look at amplitude. As waves travel, they create disturbance. The amplitude of a wave is the maximum distance of a wave's crest or a trough from its undisturbed or rest position. Think of a calm sea and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea level.
So, is amplitude the distance between a crest and a trough?
No, it is a distance of either the crest to the rest position or the trough to the rest position. Therefore, the vertical distance between a crest and a trough is in fact equal to two amplitudes.
Oh!
The amplitude of a wave is measured in meter, m. Next, let us discuss wavelengths. A wavelength is the distance between a point on one wave and the same point on the next wave. For example, these 2 points can either be two consecutive crests or two consecutive troughs in transverse waves, or they can be the distance between two consecutive compressions or rarefactions in longitudinal waves. The wavelength is also the length of one complete wave. It is denoted by the Greek letter lambda and is usually measured in meters, m. The wavelength can vary greatly. X-rays are very short, visible light is somewhat long, and radio waves are much longer. The frequency of a wave is the number of complete waves passing a fixed point in 1 second. Frequency is given the symbol F and is measured in units called Hertz, Hz. Let's look at this wave which is traveling from left to right. Can you count how many waves pass through point A in 1 second? Observe that in 1 second, exactly 3 waves pass through point A. Therefore, the frequency of this wave is 3 Hz. Lastly, let's discuss speed. The distance covered by a wave in a unit time is called its speed. Speed is measured in meter per second. Imagine seeing a flash of lightning and hearing the thunder of clouds. First, we will see the flash of lightning, and a few seconds later, we will hear thunder.
But why do we see lightning first?
This happens because both light and sound are waves that travel at different speeds. Light waves travel faster than sound waves. So, we see the light before we hear the sound. Sound waves are longitudinal waves, but the speed of the sound depends upon the type of the medium it passes through. Look at this table. Sound travels fastest in solids, then in liquids, and the slowest in air. Now that we have seen the four quantities, how are they related? Well, it turns out that the speed of waves is the product of the wavelength and the frequency. Therefore, waves with longer wavelengths or higher frequencies will travel faster. Note that the speed of a wave does not depend on its amplitude. Today, we've learned that amplitude, wavelength, frequency, and speed are different properties of waves. Amplitude is the maximum distance of a wave crest or trough from its rest position. Wavelength is a distance between two consecutive crests or troughs in a wave. Frequency is the number of waves that pass through a fixed point within 1 second. The speed of a wave is equal.
Yes, have you watched the video? Now you got the clear, is it, about this? Okay, so by this today's, let me end up the session. Tomorrow let me meet with the new topic. Okay, thank you children.